right, so let's get started. First of all, I'll just welcome all you guests. Really happy that you could join us today. If you don't mind, I'm going to remind you to put yourself on mute for the session ahead. And then I'd also like to remind everyone that this session will be recorded. So my name is Crystal Phillips, and I'll be the host for today. And I'll be the host for the first ever Biohubx Expert Corner, which will be a series of seminars about some of the most fascinating topics in the life sciences sector. So welcome, and thank you so much for joining us. My background is I am the life sciences sector lead at Thin Air Labs, which is an ecosystem studio here in Calgary. And I'm also on the leadership team for Biohubx, which is putting on the Biohubx Expert Corner sessions like today. Now, for those of you who do not know about Biohub, I'll give you a little bit of a brief before we get started. So Biohubx is a new industry-facing non-for-profit in the city of Calgary. It's a critical component of the life sciences ecosystem in the province of Alberta for companies addressing new and expanding markets. And we've got lots of those companies coming up in this province, that's for sure. So we provide space, equipment, ecosystem resources to companies advancing technologies. And we also provide support in the areas of facility acquisition and setup, regulatory and quality certification, supply chain, and capital raises. We've received close to $1.5 million in federal funding for this $3.5 million facility project. Now, Biospace One is the first facility of the Biohubx, and it's in partnership with DynaLife Medical Labs. Tenants are in the areas of diagnostics, lab services, and therapeutics. So to get us started, I'd like to introduce you to the amazing Jason Pincock. He is currently the Chief Executive Officer of DynaLife DX, one of Alberta's largest private healthcare organizations. At over 1,100 employees, DynaLife DX is Canada's most regarded multidisciplinary clinical laboratory organization and is recognized as one of Canada's 50 best managed companies. With a decade of experience at the executive level in his background, includes roles such as Chief Operating Officer, Best Financial Officer in Business Development, Government Relations. Although his professional background is financial, he was regarded for his transparent and accountable leadership style. As a creator and driver of innovation and strategy, and as a trusted and supportive partner to both government and industry. Jason has been a strong advocate for the life sciences industry in Alberta of Biohubx. So welcome, Jason, and thank you so much for joining us. I'm going to send one more reminder. Please mute yourself if you are a guest on the session. Thank you.
Well, thanks, Crystal, and thanks for the intro. I'm not sure if I have any of my minutes left, though, after that. I think you're the first person who said the amazing Jason. I like that. I'm going to keep that label. My kids will probably, I can feel my kids eye rolling right now at that comment. But welcome, everyone, and I'm actually joining from Biospace One. So Biospace is a partnership between Biohubx and DynaLife to really create the next generation of space for our life sciences companies, a place where our life sciences companies can develop alongside some industry expertise and really move the province to the next level. So it's really exciting. I'm an Albertan. I love being here. I love having a company here, and I love what we're doing, and I love being in Calgary today. So this is a pretty awesome opportunity, and it's great to see that we're kicking off with Discovery DNA. It was right down the hall from me in Biospace. We were just having a conversation before we hopped on this call. So, and they gave me a kit. I get to go try some of their technology. I really want to celebrate with Biohubx the launch of this. I think the Expert Series is a great opportunity for all of us to get sort of behind the scenes. And as you know, I have a finance background. I think you just heard that. So I'm really glad that we're talking at a level I can understand today. That's really helpful. And I love, for me, it's, kind of like our very own Bill Nye's The Science Guy, except we get a new one every time, and we get a sort of chance to look behind their technologies and their science and understand how it's going to change, lives in Alberta and patients. And so for me, that's a really exciting kickoff today. And thank you very much for this opportunity, and I look forward to this great day. So thanks, Crystal.
Thank you so much, Jason. I love the reference to Bill Nye. I haven't heard that one in a while. And I hear you when it comes to playing science with that kit. That's going to be a lot of fun, so enjoy. Lori, I believe that your mute still needs to go on. So if you can hear me, please put your mic on mute. Thank you. So next up, I'd like to introduce you to our guest of honor today, another amazing human being. His name is Dr. Aneal Khan, he's a pediatrician and medical geneticist. He's the president of a clinic called MAGIC, which stands for Metabolics and Genetics in Calgary. He's the adjunct professor of pediatrics at the University of Calgary's Cummings School of Medicine, and he's a metabolic consultant at the Saskatchewan Health Authority. Welcome so much, Aneal. Maybe we can start with you introducing yourself, adding some color to all of those fancy titles, and let the audience know a little bit more about your background.
Well, thanks so much, Crystal and Jason. It's great to be here, and it's great to be at Biohubx. So I am a pediatrician and medical geneticist, and my interest is in getting diagnosis for people with genetic diseases as fast as possible, but also in trying to fix the problem and treat them. So if you search for me on the internet, you might find that I'm the first person in the world to treat Fabry disease with gene therapy. That was done here in Calgary as a world first. Also the world first to treat a patient with Gaucher disease with gene therapy, and the first in Canada to treat a urea cycle disease with gene therapy. So those patients have been doing well. We've changed the course of the disease. And I think the time is right now to not have to sit and wait to find out what those diagnoses are. We have a platform that can find that out very fast and get people into the right treatment strategy.
Wow, thank you, Dr. Khan. I think I'm no mathematician, but I think I counted 3 world's firsts in that introduction. So congratulations on all of that, and that's pretty incredible. And we're lucky to have you on this session, and we're definitely lucky to have you here in Alberta. Can we start with with how you founded Discovery DNA?
Yeah, so one of the big issues I have is, I get asked to see children and adults that have seizures or developmental issues or some problem with their heart, some problem with their liver, some function issue. And we know in many of those cases, we know that under a year of age, the #1 cause of death in children is some type of genetic disease or abnormality they're born with, what we call congenital malformation. And when they're sitting in the ICU, I need a rapid diagnosis. We need to find out what's going on with them so we can get the right treatment working. And there wasn't a fast way to do it. All the testing in Alberta right now, clinical grade testing, is still sent out of the province. So I said, well, why don't we just set something up here? And that was the founding thought behind Discovery DNA. And now we have a platform where we can do rapid gene sequencing. So between 2 to 3 days, we can turn around what the genetic diagnosis is. So an example would be I had a patient who had been seizing for 1 to 2 weeks, had 2 MRIs, 20 different tests, and nobody could figure out what was going on. And we took a cheek swab, we ran a gene sequence exome on the patient and found what the disease was, and then we knew what drug to use to treat it. And that was 2 years ago. Since we started the drug, he has never seized again, and he's developing normally. And there's a video story of him on the internet. So that prompted me to think we need something like this in Alberta. We shouldn't be having to send our information overseas for testing and waiting months and months to get a result. We can do it right here, and that's what we've established. We have rapid DNA sequencing diagnostics available right here in Alberta.
Wow, with powerful stories like that, I can see your motivation to just roll up your sleeves and make it happen here. So that's pretty incredible. And if I were to back up a little bit, can you talk a little bit about sequencing, let alone rapid sequencing? What does that exactly mean?
Sure, absolutely. So when you look at our genetic code, we have 3.5 billion base pairs of genetic code. And that's a lot to go through. So if you had to go through many encyclopedias to find, let's say, a spelling mistake that may be causing a problem, that technology is relatively new and is something that we wanted to bring to bear as a service here. When you look at all your genes, that's something called a genome or whole genome sequencing. That's a lot of sequencing. But you can look at a section of your genes that we know cause the majority of disease, 80 to 85% of the disease, and they're what we call coding regions or exomes. And so you can get your best bang for the buck with an exome, or you could do the entire genome. And right now, we're the only lab accredited to do whole exome and whole genome sequencing in Alberta. So we're accredited with the College of Physicians and Surgeons of Alberta. The other type of sequence people don't think about is mitochondrial sequencing. And I deal a lot with that. I've done hundreds of biopsies on children and adults while I've been here. And, you know, a biopsy is a little painful. I try to do the best I can. So I said, we need a method to sequence the mitochondrial DNA. And we have a world unique method for sequencing mitochondrial DNA from a cheek swab. So those are the different type of sequencing patterns we use. We also have something called pharmacogenomics, where we can scan the genome and detect changes that might change your response to certain medications that you're on, whether it's a cholesterol medication, one of the medications for mental health or depression, or any number of other different medications. We can determine whether or not your dose needs to be changed. So that's where the DNA data empowers decisions in medicine. And it's not something that was a big part of my training, but now we're finding more and more it's hitting every aspect of medicine that you can think about, and is going to be a regular component of trying to sort out what to do with the patient's health.
I love that it not only addresses precision and personalized medicine, which is, like you said, the way of the future, but it also could have a benefit in preventative as well, wouldn't it?
Yes, it can be part of understanding, you know, if somebody's starting to have mild symptoms for something, what they have. It's always easier to change the course of a disease when you find it early. Finding out when there's been significant organ damage is always a lot harder. So the average wait time people have for one of these diseases, which actually affects 10% of the population, is 8 to 9 years until they get through the volley of doctors and to somebody who might order one of these tests. And if you ordered one of these tests in Alberta, you could wait 6 months or more to get a result. And that's a long period of time if you're not in good health. So we've shortened that down to a few days, and we hope that early detection can help patients find better paths towards health.
Wow. So from months to a few days, and this can all be done in the inside of your cheek. Now, can you explain why the cheek?
So the cheek has layers of cells we call epithelial cells. And so we have used different sources of DNA. Lots of people are familiar with blood as a source of DNA, which works fine too. But you can imagine then you have to go to a lab to have a blood test done. And then you can imagine with the patients I deal with, small babies, of course, it hurts even getting a blood test. Well, to some adults, it hurts too. So saliva is another method of getting cells, but particularly for the one type of sequencing we've been doing, which is mitochondrial DNA sequencing, where I had to get muscle biopsy before, we found the results were better from a cheek swab in terms of the type of DNA and the amount of DNA we could get. And also in a newborn baby, where you don't really want to do a muscle biopsy, and they're not going to give you a lot of saliva, despite the fact that they may be drooling all the time, but you might have difficulty collecting it. The cheek swab takes us 30 seconds and gets us enough DNA to run all of our tests.
Wow, glad I asked. That's really interesting. So now the process is only a few days long. Can you walk me through that journey from a patient's perspective? Say they hear about this and they want to get involved.
Absolutely. So right now, for example, we get patients that contact us from throughout Alberta and throughout Canada. So I had a family contact me regarding a teenage boy who was losing his sight and was going blind. And they were from the northern part of Alberta. And the mother said, well, it's going to be 6 months before I can get testing access. Is there something you have? I said, why don't you come in next week and we'll talk about it. And we did a cheek swab. We ran a test and made a diagnosis really in less than 2 weeks. And now that patient is on treatment and may qualify for certain types of gene therapy, which if they waited another 6 months, he would be completely blind and not be able to qualify for it. So the process is very fast. At our clinic, we can see you based on how urgently you need to be seen. So if you needed to see me tonight, it was that urgent, or if you were in a hospital, I would go into the hospital, collect a sample, and we would do a rapid analysis right away. So if I took a sample today, by the weekend, I would actually have done all the sequencing that normally through the standard system may take weeks or months to get an answer on. And that's how we've changed the time frame, and that's how it works. So whether you're seeing me in clinic or whether you are in a hospital somewhere, we can send the cheek swab kit. It can be collected and shipped back to us, and we run the sequencing very quickly. We have a project right now through Genome Canada with Shared Health in Manitoba, where we're trying to use this approach and say, run the gene testing first if you suspect a genetic disease, rather than ordering a bunch of MRIs, doing biopsies, and doing those other things, because it actually has a higher yield. And there were 2 recent very large papers that came out in the New England Journal of Medicine a little over a week ago, and in JAMA Pediatrics, large studies that show in children who are born with problems, congenital problems or genetic type problems, that this method is the highest yield of any other type of test that's out there.
Can you speak to how common genetic disorders are?
Absolutely. So for children under a year of age, as I said, it's the number 1 killer and cause of hospitalizations, because normally you would expect, well, that's where you might see children born with heart problems or liver problems or mitochondrial problems. If we look at the population as a whole, though, it still affects 10% of the population. So that is 3.5, maybe 4 million Canadians. Worldwide, that's 350 million people, which is larger than the population of the United States, have some type of rare genetic disease. And what we're finding with technology is there are new treatments that constantly are coming in to treat those diseases. So a lot of those patients, they don't even know they have one. They're either suffering from complications, they don't know how they're going to get access to the testing to even know that there may be a treatment for the disease. So it is a not that uncommon of a problem. The issue is each of those diseases is very rare. So the average physician may never see a case, but every physician has a group of cases of some type of rare disease. So you need a test that can scan a wide array of genes, which is what we do, so that we can find things, even if the doctor hasn't thought about it, we find things. In fact, I get surprised myself. I'm like, oh, I never thought of that disease. And out of the sequencing pops out that disease. I'll give you an example. A patient saw us recently, and we ran the sequencing tests, and it came back a gene called XTXBP1. Now, who knows what STXBP1 does? If I might only see the case once in my lifetime, but it was the sequencing that gave me the answer. I could have sat there and tried to look in between the toes and look in the eyes for years and never have come up with that idea. And that's what has changed the game, a rapid answer through sequencing.
Wow. So do you have to have a symptom, or do you imagine that the future of health is going to be everyone's genome will be mapped, and you kind of start at that early age?
People have been talking about that. Right now, our focus is on people who have health issues or on medications to help them find a better approach. Somebody might not be responding to certain medications, for example, they're trying different pain medications and so on. And so a pharmacogenomic test might tell them whether or not they were expected to respond at that dose. So right now they're health-related concerns, but we know in Alberta and many provinces, we have what's called newborn screening for a lot of these conditions that are metabolic or genetic. And I think over time you can see in the United States, there is more involvement of genetic testing to find these diseases early so that they're not as fatal. We know for many diseases that makes a difference. So there's a group of diseases, for example, called fatty acid oxidation defects. A lot of those diseases would have a pattern where a child was found deceased in the morning, died in their crib, and we don't see that much anymore because they have newborn screening and we know what they have before they're a few months old when they're going to get hit with that issue. And so we can deploy this also for many other things. The province has a project right now to use it for something called spinal muscular atrophy, so that's detected earlier. So we are going to see more use of gene sequencing to find early disease in patients so that they don't suffer the complications that they would have without it.
So with this trend in health, with the momentum with Discovery DNA, how are you going to scale? Because I mean, you're a perfect fit at Biohub, and Biohub is one of those places for companies who are going to scale and make impact at that higher level. What are your plans there?
Absolutely. I think scale is our next goal. It is possible to scale, and I think it requires some planning. You might say it requires cloning of some of the people that do our sequencing. I suppose that's an experiment we can't do right now. It's technically possible, but let's not go there. But I think we want to bring more informatics into the game, artificial intelligence for processing. We need to bring more skilled people who can analyze sequencing data, and of course, as would be normal, more equipment and staff and facilities to do the processes. So, but it's an easily scalable technology. There are some sequencers that have the capacity to sequence all the needs of all Albertans with a unit that will fill maybe a few big desktop printers or things like that. That's kind of space. So high throughput sequencing is certainly possible, and that's what we want to do. We want to bring this technology so patients can get a diagnosis faster. We also want to inform governments that they don't have to send their sequencing outside the province. They can do it through us at Discovery DNA. And one advantage of that is right now what's happening is when you send your DNA outside the province, guess where your data is being stored? And so if you want to look at the effect of different environmental factors, different things in the water, different other issues, local issues with high blood pressure maybe, or local incidents of diabetes and what's happening, you don't have access to the data. We are giving our data away. And at Discovery DNA, we have a sovereign Canadian server where we retain that data so that you can look at the data anonymously to find trends that might help understand what's happening in your local population, and also our special populations. So our First Nation and Aboriginal populations, Mennonite populations, Hutterite populations. How is somebody in another country going to understand what to do with that data? I think we need to have the data here. We need to have the systems here where we can study it. And that's what we're trying to accomplish.
Thank you for that. That's so on the topic of data. How do you ensure the privacy and security of all that data that we will now keep in Alberta?
Well, that's a very good question. So, of course, what we looked at is, are we going to do that privacy and security ourselves, or do we find somebody who might be able to do a better job? So we decided that we are a sequencing company. That's our forte. And for privacy, we approached Microsoft, and our data is kept on Microsoft Azure servers. And Microsoft was kind enough when I said to them, we want Canadian sovereignty of the data, so we'd like your data storage to be within Canada. So we have in Canada servers, and we looked at different security glitches that took place, and we're confident that we would get that type of security through Microsoft. The other things that one can do is, of course, use encryption and other methods, which I won't mention here for security purposes, to make sure that even if there was a data leak, you could not identify who that person was. And it's anonymized data. And we'll continue to work to ensure that that security is retained.
So with all of this data collection, and say it's anonymized or not on your end and from your view, what are some other big questions that you have that you want to learn at the population level through the work that you're doing?
Well, I think from population data, it would be important to know what the incidence of certain diseases is so we can target them. For example, we know in the Hutterite community, some diseases are more common than we thought. A condition we published on not too long ago called dilated cardiomyopathy and ataxia. In fact, the history is most of those children would die before they hit 5 years of age. It's not on newborn screening. But if we don't understand what the population frequency is, then we may not be able to advocate that it's something that we should screen for. A variety of other diseases, cancer, certain types of cancer, of course. How do we screen for those? How do we make informed decisions about what's in our population? So that's another area we're expanding into. So I think this local population work can help us give an idea about what we need to focus on, where our resources need to focus on. And also with these rare diseases, if we find them, we can find out whether some are more common in our population than others. That can inform policy in terms of what type of drug approvals should be focused on from government to pay for the medication that can change the course of the disease. And some things that we don't have a lot of, then we can decide, how to deal with those or whether to rely on other people's expertise for those. So it allows a triage process to take place. And we know these situations exist. I gave you some examples in Alberta. We know with our colleagues at Shared Health, there are a lot of founder mutations in local populations. So you can't look at it as one block. You have to look at regional situations and focus on how to care for those people, whether it's cancer or rare genetic tests or things like that.
So you're talking about, populations, ages of all kinds, but you're focused in pediatrics right now. Will Discovery DNA focus on adolescents, adults, seniors?
Well, we do. I mean, I started my career off as a pediatrician, but most of my patients are actually adults. So I do a lot of adult medicine. And these could be a situation where somebody comes in with a severe muscle disease and they're incapacitated and in an adult ICU. So I go to the adult ICUs too. And we have found conditions like fatty acid oxidation defects in them or mitochondrial diseases in them and been able to help them. What's changed with a lot of those adult situations is if you had one of those diseases, it would be regarded as fatal in many circumstances. And what we've used is an approach that says, well, let's find it fast before it causes severe complications. And then let's use whatever knowledge we have to change the course of the disease. So for mitochondrial diseases, for example, many people come to me and said, oh, I think I have this thing, and now I'm not going to live very long. And what I say to them is that's not our current knowledge. Our current knowledge is that, yes, it's a chronic disease. Yes, it's going to have an effect on you. But, a lot of my mitochondrial patients allowed me, if they passed away, to do autopsies. And what we learned is they actually didn't die of the disease. And by knowing what the genetics was, by knowing their history, what we're able to say to people now is, you're going to be okay. Yes, you have some challenges you have to deal with, but we're going to modify how we look after you so that you're as healthy as possible. And so, ironically, most of that work for me is in adults.
So what if you are not a patient? What if you're someone who's just, a biohacker, wants to know whether they have the cilantro gene, whether they like or hate cilantro or it tastes like soap? Isn't that a genetic thing?
It's a genetic thing. Like everything, like if you looked at me and said, hey, is this guy going to break the world record for the 100-meter dash? You could confidently say no. And that has a lot to do with lack of training, but also genetics, right? You look at Olympic athletes, genes have an effect on their performance. Some of that we don't understand very well, but we know it's there. We understand rare diseases or single point mutations in genes a lot better. So when we look at somebody who's healthy, we still know that a lot of the population is on some type of medication. So they may want a pharmacogenomic profile to understand whether that medication is being given at a suitable dose for what the intended use is. Everybody's got a family history of almost something, and they may want to know whether they're at risk for that. So we don't necessarily run genetic testing on everybody, but we do counsel everybody on whether or not that genetic testing will inform them. But a healthy individual, if they wanted to know whether they have the autosomal dominant gene that allow them to detect asparagus in their urine, and if they want to find that out, we have that information. We usually don't mine it because we are after serious medical information. It's not something I would use in clinic, but the data is there. Patients can get their data. We give them their data, and they can decide whether they want to talk to some other researcher or deal with some other place that might pull ancestry data from there, or may pull out some of those interests. I guess, for lack of a better phrase, what we call genotainment. So those I would pass on for somebody else to look at. We would look at the serious stuff, but the information is there in the sequencing that we do for a large part.
Thank you. And that was a new term for me. I like that. So before we go on to Q&A, and for everyone who's listening, if you have a question, please put it in the chat. I'm going to ask one more question, and then we'll get to all of your questions. We've got another 15 minutes to go. So I'd like to ask, how do patients access Discovery DNA? What's the first step for them?
Basically, they either they or their physician or their advocate, parent, or somebody really request an appointment. We sit and talk to them about what their questions are that they want answered, what their needs are, and we there's no fee for the consultation. It's I'm a practicing physician, and I use the public system to do the medical consultation. And then we go through a variety of choices that they have. We can still access the public health system to do certain types of genetic testing, which they may or may not decide they want to choose, and many do. And so they can choose that route. Right now, because we're so new and because we haven't had any formal talks to see how to integrate our services with the provincial services, if they wanted to do any of the sequencing, it's private sequencing. We also look to see if there's things that we can't do. And there are some that aren't covered by exome, the diseases. There are some tests that aren't done in Canada at all, and we would advise them that even if it's not funded, that they would have access to that test wherever it is in the world. So we provide a full consultation in clinic to allow them to understand what their choices are and how they can make those decisions. In many cases, what we found with sequencing is there is insurance coverage to cover that. So we look into that too, so that they can make those choices.
So you're working with government, fellow physicians, scientists, manufacturers, and it's all working together. And this is in the name of the patient, and a lot of impact being made. So we have a few questions from the audience. First one is from Christy. Where does Alberta currently send most of their sequencing?
So Alberta currently sends their sequencing to a variety of different labs. They're all outside Alberta. So, for example, Blueprint Genetics, which is headquartered in Finland, Prevention Diagnostics, which is headquartered in the United States. It could be Gene Diagnosis. There's a number of different labs, but they're all outside the province. Like I said, we are the only accredited exome genome sequencing lab in the province.
Do you expect to market to and accept people coming from outside of the province into Discovery DNA?
Yes, well, I get a lot of requests because, similar bottlenecks exist in many different provinces. So whether they're from British Columbia or Saskatchewan or Manitoba or Ontario, I do get patients from across the country.
Okay, and so the next question, for critically ill who take fistfuls of pills, could a pharmacogenetic review help reduce the number of pills they need to take?
That's a very good question. Well, that is the goal. And now I can't guarantee that, of course, but we know that that's the information that we get sometimes. I'll give you an example. There's a patient, when we started doing the testing, we did a pharmacogenomic profile, who was having uncontrolled seizures. We did an exome and a genome. We couldn't find a single gene that causes it, but that happens sometimes. Sometimes it's autoimmune. But there was so much difficulty controlling the seizures. We looked at the medications they were on, and we found out they're actually all processed through the same channel. So the strategy there from the pharmacogenomic profile would be, okay, you're on 20 drugs that say they're being processed in a similar way. Maybe you need a different way to process, or need to choose drugs that are processed a different way. Maybe the genetics of that protein channel cause it to work slowly. So I do think there are going to be cases like that where they will help. And there's every day when I see patients, I go through the list. People are on 20 different medications, and I always wonder, do you need to be on 20 different medications? Maybe if we selected ones that would be tailored, that would help. And there's, I'm involved in a lot of clinical trials. For example, there's a drug that's called iliglustat, which we're studying right now in children for Gaucher disease. And you cannot dose that drug unless you have their pharmacogenomic profile. That has a direct determination on what your dosing is going to be. And we're going to find that for an increasing number of drugs.
Thank you. Kyle's asking, are you able to share what type of methodology you use for your rapid sequencing?
Yes, in a general sense, of course. The little secrets we have in the lab will keep out of it, right? So if you look at our standard exome genome platform, we have a variety of sequences. We have Illumina-based sequencers. We have a Thermo Fisher INS5 sequencer as well. And we are also looking at PacBio sequencers, long read sequencers. And we also use what is called nanopore sequencing, which you may have heard of out of Oxford. For mitochondrial DNA, for example, long read sequencing is very important, and you cannot access large deletions without long read sequencing. So we run our mitochondrial DNA sequencing primarily through nanopores. Now, what makes it super fast? Well, one of the reasons is access. I don't sit around with lots of applications and forms and things and offices I have to send it to. You come and see me, I say, you want it? Here's a cheek swab, send it to the lab starts working on it. So that cuts down the delay in just processing things. The others have to do with how we run the sequencing and optimization of what we call libraries, optimization of the actual sequencing, enriching targets. I'm mentioning those words not because I expect everybody might know, but there are methods that you can use to enrich and speed up testing. But a lot of it is to not waste time.
I like the urgency that you feel. We talked about how the patients can access you and what their journey looks like. What about pharmacists or other physicians or even allied health practitioners?
Well, absolutely. So nurse practitioners, pharmacists, people interested in, let's say, pharmacists a lot of times may be interested in the pharmacogenomic profiling. And so we're happy to speak with them. I speak with some of them on a regular basis. I won't point them out unless they want to point themselves out. But we work with them to suit their needs and try to look at different markets where our pharmacogenomic testing will have some value. And there's a need for it in Alberta and clinical grade stuff, not just sort of, hi, this is interesting, but stuff you could make actionable decisions on. So we're happy to work with those people. Their scope may be slightly different. So if you're working with a medical practitioner, usually what they're after is a diagnosis. Tell us what this disease is. And there are certain individuals licensed to perform that task. And other individuals may be looking for information for other purposes as well, whether they're nursing or pharmacists and other professionals, researchers.
Okay, thank you. So the next question is what is the cost of getting one's genome sequenced? And I'll just add to that question
Sure.
a little bit. What's the cost now? And what did that journey look like cost-wise over the last decade?
Well, the first human genome sequence that came out was during President Clinton's era. And it was a few $1 billion. So it's come down since then. So a standard exome, if you go to our website, a standard whole exome sequence is $2,000. which is comparable to a price that, let's say, the province would be paying for sequencing outside the country. We didn't want to make it, any more expensive. And the pharmacogenomics is around $500 for a clinical grade result, because we are an accredited lab. And of course, because the pharmacogenomics is a new platform right now, we can provide a discount on that if anybody's interested. The cost of a whole genome. So remember I said how an exome is a small fraction of the genome, but it's the best bang for the buck. So that exome is $2,000. The genome we are running at cost. It's between $7,000 to $8,000. It depends on multiple different factors. And so if we see a patient in clinic, I will advise them the route they want to choose. Now, some folks come in and they're like, we want the best, heaviest, biggest test you have. And no matter what I say, they're like, just do it. and it is a valid test. And we have found answers that way. So we had a family come in, their daughters were, more than 8 years of age. They didn't have a diagnosis. And one of the primary labels was autism. And they said, we want a whole genome. So we ran a whole genome and bang, we found a gene. And I said, this is what they have, and this is going to be their treatment path. So it will produce answers too.
We've got time for maybe one or two more questions. Next one is there any of these tests that are covered through the health plans of your province?
Yes, they are. So your health spending fund, we've had people get coverage through there. We've had people get coverage through different insurance companies as well. And so each will be a little different. There's applications that are different for those, but we do advise people that if they have coverage to at least pursue that to see if they can get the testing covered.
Nice. And so can you remind me once again, what's the best way for people to reach out, learn more about Discovery DNA?
So you can go to our website, discoverydna.ca. We have some learning videos there. We have some basic information on the type of products we have, what an exome is, what gene sequencing can do. Of course, if you're familiar with the medical literature, you will have no problem finding a plethora of information on what gene sequencing has done as an impact on healthcare. And I have found whether you're using YouTube or internet searching as well, you can get some fairly decent information from people and seminars and series on the value of sequencing. Or you could just call me. You can go through Discovery DNA or Magic Clinic website and give me a call, and I'm happy to talk to you and explain, what the technology and the process looks like, or any questions that you might have.
Perfect. Thank you. There's a request in a private message if we can get a group photo. I'm not sure how that will look.
All right.
Does this need to be read?
A group photo. I don't know.
Either.
Everyone would need to turn on their cameras.
Okay, so everyone.
Oh, I see.
So if anyone is comfortable with the group photo, please turn your cameras on. Look at that, Dr. Khan. It wasn't just the two of us.
Oh, well, I think there's multiple pages. I don't know how we'll capture that, but okay.
While people are turning their videos on, I'd like to take this opportunity to thank everyone again for coming here. Thank you, Dr. Khan, for a fascinating conversation. I have definitely a few follow-up questions that will probably keep me up at night because it's just too exciting and interesting about the future of medicine. I'd also like to thank Biohub for putting this on. I know Elisa worked hard to make this all happen. And we also have some sponsors, that's Prairies Canada and Dynalife Medical Labs. We are so happy to be included in Calgary's Innovation Week as well. That's this week. So thank you to Startup Calgary for that opportunity as well. For anyone who's interested in learning more and to stay updated on future events, there is a free membership form that you can fill out on Biohub's X's website, which Elisa will put in the chat here shortly. So it looks like we've got a few cameras on. So Elisa, are you ready to take a picture if I say 1, 2, 3, smile?
I am.
All right. Okay, so 1, 2, 3, smile, starting now. 1, 2, 3.
Perfect.
Thank you, everyone. It's been a pleasure. We're right at 12:45. I really appreciate all of your time, and I look forward to the next one.
Thank you all very much. Have a wonderful day.